Well, here I am again. I'm going to continue the series here about programming in Hopper for people who are already familiar with curly brace and semicolon languages, especially the modern ones like C# and Java, but C or C++ will do as well. So I'm focused on the things that are different. So one of the things I briefly introduced in the previous video was the idea of units, and I was using the system units. Units are a way of breaking up the compilation into manageable chunks, or you can do it for two reasons. The one is to organize a large project better, and encapsulation is one of the tenets of object-oriented programming that makes a lot of sense in all environments, not just object-oriented programming. So you'll put functionality that's related to a certain component or module in one place, and you'll try and hide the implementation details from the rest of your project or from your users, your customers. Anyway, this concept of units is something I first encountered in Turbo Pascal. It was introduced in version 4. They saw the idea in UCSD Pascal, or also how Nicholas Wirth introduced modules in Modular 2. And one of the reasons Borland introduced units was to do separate compilation to improve the speed of the compile. But at the same time, it also did the encapsulation thing. My main reason for it is the encapsulation thing. Since I don't keep the binary of the units, I compile everything every time. And the reason I do that is because it makes it easier for me to only compile the methods that are actually used by your program. So I don't compile unused code, so there's no dead code. Anyway, I take advantage of the unit system to do that. If it's not touched, it doesn't get compiled. So I don't have to go through some existing compiled binary and strip out what's not used. Anyway, time to move on and show you what a unit is. So the first thing we'll need to do is make a file for our unit. So we'll say make me a new file, same folder as where I am, and I'm going to call it my unit.hs for Hopper source. There we go. I'm not going to put anything in it. I'm just going to go back. Now I'm going to use a user statement to use my unit. And where did I say we were? We're in source samples my unit. You can put the extension on, but why bother? It's prettier if you don't. Users, as I've mentioned before, is similar to using in C# or Java. And it's sort of similar to include in C or C++. The reason it's similar to include is because it's actually including the source code, and then it's going to compile it. So it's not quite like using, which is just using an already compiled assembly in C#. It's more like include. But unlike include, the order doesn't matter since it's a two-pass compile, whereas with include, the order does matter. And include also needs the library file to be included somewhere as well, which this doesn't. So it's users is a better name for it. Anyway, let's go look at our, here's our unit. So if I try to compile this right now, it should fail. And it's going to say it's expecting the word unit in the beginning of my unit, if you look at the bottom of the screen here. Let's go have a look. So it wants the word unit. So let's use the compiler again to learn the syntax. So we put the word unit in there and compile. Now it says it wants a name for my unit. I'm going to call my unit, same name as the file, but it doesn't need to be. As in the same way the test is actually my program, it doesn't matter. Similar to C# and Java, this also doubles as a namespace. So if you have ambiguity between multiple units, you can qualify the name of a function with the namespace. And we'll do that. So we're going to create another println here as a method. It's going to take a string and we're going to, in our println, we're going to take that string and we're going to convert it to upper. And then we're going to call the other println to print it. Now, if I just leave this like this, it's going to be recursive. It's just going to call itself. But if I qualify it with screen, it'll call the other one, right? Still not good enough yet, but we'll see why. So I've now got a method in my unit. So let's compile this. So it's happy with it, it compiled it, but we're not calling it yet. So we can see if we're calling it or not, whether that prints uppercase or lowercase. So if we run test and we go lowercase here, we're still getting lowercase. So it's not calling us. So a little peculiarity here. Why is it calling the one in screen and not the one in my unit? And the reason is because it's defined first. So if I qualify this with my unit, it'll call mine. So let's build it again, and then we'll test lowercase, and we get uppercase. So now it's calling my one. All right, you now know how to make a method in your unit, your own method. If I gave it my own name, then I wouldn't need to qualify it. So if I did that, and I went in here and made it new println, I wouldn't need to do any of this qualification. I could just do all that with a nice, simple, short version. So let's run it, test. There we go. So only need to qualify if it has exactly the same name. And also if it has the same argument signature, so you can have overloaded arguments. So if I had a unique argument signature, I wouldn't need to qualify it either. So I could extend print by having a print with extra arguments. Okay, so that's probably in a nutshell what the units are all about. I'm going to go on a little further here to explain visibility, since we did talk about encapsulation. So let's say I wanted to make myself more of a camel case naming, because that's my thing. So I put a lowercase n on there. Now I build this, and in the bottom here you see it says my program new println is not defined. Why my program? Well, I try to use something starting with a lowercase character inside my program, so it thinks that this should be defined here. And the reason is because Hopper treats the first character's case as the qualifier of whether something is private or public. So coding convention is enforced. If it's a lowercase character, it means it's private. So this method cannot be seen outside of my unit, because it's and it doesn't even know that it exists in my unit. So since it's giving me that error message at the bottom is saying it thinks it should be locally defined here. So the same is true of defining like a global variable. So if we put a prefix in front of this, let's say we're going to string prefix equals prefix, like that, and we're going to pop that in front and build it. And now we'll go out and test it with lowercase, and there we go. So we've got the word prefix in front. If I try to print prefix here, as you would expect, it shouldn't compile. Prefix is not defined, right? So it's sort of get your head around it. This is a global variable at the global level. It's not defined inside a method, it's defined inside a unit, or it's defined inside the program. So if it's defined just after the first curly brace, it's global. But just because it's global doesn't mean it's visible outside of the unit. Now we try something else. We put an uppercase P on our prefix. Member variables must be private. So you can't do that. You can't expose a public variable, a public global variable from a unit. If you wanted to do that, the way to do it would be to make a property. So I could make a property called prefix with a getter in it and say return prefix, like that. So that is allowed, and if I went to test, and I could now say print prefix, and I don't need to qualify it because it's unique. And so properties are the way to expose. With a getter and a setter, you can put a setter in here as well, just like C# and Java. That's the way to expose something other than a method or a function call from a unit. I mentioned a function call. Unlike C, there's no void in front of something that doesn't return a value. So, and this doesn't require return at the end. Whereas if I put a return type and I try to compile, it's now a function. So two things go wrong with that. The first one that goes wrong is a function cannot be used as a method. Return value must be consumed. So over here where that error was, I have to consume the result if I want to call a function. And it may seem clumsy, but it also makes you avoid a whole class of errors where you've forgotten about the fact that your function's return, or you think you're calling a method instead of a function. So if I compile that now, it compiled here, but when it tried to compile this method, it says there's no return. So I have to put a return here as well. You can't just exit a function that's returning a value without returning the value. So that's the difference between a function and a method. There's no such thing as void in Hopper. If you return a type, it changes from being a method into a function, and you have to have a return type. This is also an artifact, something from Pascal, where Pascal, unlike C and C# and Java, where they just have methods, and a function and a method are pretty much the same thing. One has a void return result. In Pascal, they did separate the two concepts. So they had procedures and functions to distinguish the two of them. I call them both methods in Hopper, but I should be calling them functions and methods. Yeah. Anyway, I think that's enough about units for now, and about when things are private or public. So I didn't litter the Hopper code with all these different adjectives for describing whether something's visible or not, because it's not as complicated as a language like C++, where you've got protected, public, private, virtual, static, or like in C#, internal. It's just an alphabet soup of these adjectives you need to put in front of your exposed methods and properties and variables. So in Hopper, it's plain and simple. If it's a lowercase alphabetic character, it's private. If it's uppercase, it's public. Moving on. Thanks for watching.